First of all, you create an S7-SCL source in the source container of the Step 7 program and then open it with a double click. You can create the necessary code structure very quickly by using the development environment. The code generator automatically generates the code lines required for an FC. The interface of the FC has already been defined conceptually. The array to be sorted is a gateway parameter. Furthermore, a status should be returned. Now we have to implement the sorting algorithm. We will proceed from the outside in. We first create the external for loop and fill this with the necessary variables. Since the entire array is to be seen as unsorted at the beginning, you have to select the appropriate run parameter. Index 1, therefore, must be run here from the upper bound of the array to 1. In this case, the constant max size is the upper bound of the array. The current structure element and the current index can each be marked with one line of code using the assignment operator. Now you need another for loop to find the maximum in the unsorted subarray. This loop starts at the beginning of the array and goes to the end of the unsorted subarray. Index 2, therefore, must run from 0 to index 1 minus 1. You can now use an if statement to determine the value and position of the maximum. Finally, you have to check whether the maximum found is in front of the current value. If it is, then the values have to be swapped. If not, then the maximum is already at the end of the unsorted subarray. The core code lines of the algorithm have thus been implemented. In order to obtain a program with correct syntax, you simply have to add the missing variable declarations. The compiler is now triggered to check the syntax of the S7-SCL source. Any errors are displayed in the output window. You simply double-click the error message to jump to the error location. In this case, a semicolon was missing. Once you have corrected the error, you start the compiler again and the Step 7 block is generated. Now this block can be called multiple times by another block or even by another S7-SCL source. The functionality should now be checked online, because often errors are only discovered during runtime. First, the S7-SCL block is loaded into the automation system. S7-SCL gives you two options for checking the functionality: program status and single step mode to monitor variable assignment step by step. To monitor the program status, you simply click on the spectacles icon. In this way, variable assignments that occur during the block run can be observed online on the CPU. This is useful above all in finite state machines where statuses last for several cycles. With this function, however, you can't see very much, because the changes happen so quickly. In the case of highly dynamic processes, like the one we have here, it is best to use the single-step mode with breakpoints. In just a couple of clicks, the controller will interrupt the cyclical operation at the breakpoints. By going through the code step by step, you can have the contents of each variable on the CPU displayed. The error search is simplified considerably in this way, making it possible to do simple module tests beforehand with S7 Sim, for example. This reduces even more the risk of having to change the code on the plant and can thus shorten the commissioning phase enormously. In conclusion, you can see that the sum of the options put at your disposal by S7-SCL enables you to minimize costs considerably.